Hello everyone and welcome back to a brand new video. And in this video I will be covering problem D, that was Madoka and the corruption scheme, like I said in my last video. And the problem is a bit hard, so if you guys have a doubt or you guys feel like you're missing something, feel free to join my Discord server. I will leave a link in the comments, so be sure to check that out. And with that out of the way, let's start with the problem. Yeah. So in the problem, we have been given a game with n rounds. And we also have been given an integer k. I will explain what k is later. But for time being, we have been given a game with n rounds and to the power n participants. So in every round, 2 participants will face off and the winner goes to the next round and the loser will be eliminated. We can draw an example for n equal to 3 and we can explain how it works. So let's say we have game 1, 2, 3, 4, 5, 6, 7 and 8. So let's say 1 wins, let's say 3 wins, let's say 5 wins, let's say 7 wins, let's say 3 wins again here, let's say 5 wins here, and let's say 3 wins again, right? So that is how the game will look like. So we have n rounds and we have to the power n participants. Also we have some powers, right? We have the following powers. We can change the initial configuration. Of matches. For example, let's say we have 1 and 2 here, right, in the first round, and 3 and 4. We can change the configuration. So we can, let's say, face 1 against 3 and we can face 2 against 4, right? So we can change the configuration. That is the first part that we have. And the second part is that we can decide the winners, right? So it is up to us to decide the winners. For example, we chose that 1 wins here. We can also choose that 3 wins here, right? So we can choose winners however we like. We can choose winners however we like. So these are 2 powers that we have. But the committee also has some powers, right? So that is where this integer k will come in. So the committee, right, also has some powers. They have been given an integer k and they can change outcome of at most k matches. For example, let's say my n is equal to 3 here, right? Let's say my k is equal to 2. Then the committee can change outcome of any 2 matches. They can, let's say I'm winning 3 here, they can change this outcome and make 5 win here, right? And instead of, let's say, having 3 win here, they can have 4 win here, right? So they can change the outcomes, right, of any 2 matches. So that is the problem. And what we want to do is we want to choose an initial configuration. And outcomes such that our winner is minimized. After committee applies k operation. So that is the problem. So we have been given a game with n rounds and to the power n participants. We can choose the initial configuration, we can choose the winners, and there is a committee that can change the outcome of k matches. So given this, we want to choose an initial configuration and make outcomes such that our winner is minimized at the end, even after the committee applies k operations. So that is the problem. So how can we solve this? So to solve this, we will start with some observations. So let's start with the solution. And let's start with observation. So the very first observation that you need is that we need to change at most one edge or outcome in every round. This is at most 1, right? So take care of this. For example, you can draw 1, 2, 3, 4, 5, 6, 7, and 8. I hope you are able to see this. So let's say my 1 is winner here, my 3 is winner here, my 5 is winner here, and my 7 is winner here. Similarly, my 1 wins over 3, my 5 wins over 7, and my 1 wins over 5. So how can you tell that 1 is the winner, right? So there is a easy to tell that 1 is a winner. So if you see, my winner is someone, or my winner is a leaf node that has path up to root. So as you can see, my 1 is a leaf node and there is no other node that has path up to root, right? So this is my root node. So only my 1 node has path up to root. And there is only one unique path. So there is only one unique path from leaf to node. That is my winner. So as there is a unique path, there will only lie one edge, right? There will only lie one edge in every round because there's a unique path. So it will go from root to leaf, and in every level there will only lie one edge. Right? For example, this is my second round and I have two outcomes here, right? This is, let's say, my outcome 1 and this is, let's say, my outcome 2. But there is only one edge that is going through round 2, right? So why will I change outcome 1? As you can see, my outcome 1 is not lying on the path, right? My outcome 1 is not lying on the path. So even if I change outcome 1, it won't change anything, right? So the only outcome that I need to think about is the outcome that is lying on the path. So you only need to change one outcome, right? Why would you change two outcomes? Because only one outcome will lie on the path. So in each level, you only need to change one outcome. So in each level, we change at most one outcome or edge, you can say one outcome or edge. So that is the very first outcome. So that is the very first observation, right? So the winner is someone that has a path from leaf to node. There will be a unique path, and for a unique path, one edge will lie in every level. So if you try to change two outcomes in same level, it will be useless because only one edge will lie on the path, right? So how can we solve the problem using this? So I will draw the same example again and tell you how you can solve this. So let's draw the graph again, or tree if you want to be precise. 1 wins, 3 wins, 5 wins, and 7 wins. Let's say 1 wins again. Let's say 3 wins again. Sorry, not 3. How can 3 win? Let's say 5 wins again. Let's say 1 wins again. And let's say my k is equal to 0, right? So if my k is equal to 0, that means I cannot change any edge. Right? So let's say my left side edge, right? My left edge is I will denote it with 0 in binary, and a right edge I will call 1 going forward, right? I will call a right edge 1 and a left edge 0. So if you see, I have a 0 here, a 0 here, and a 0 here. So who is my winner? My winner is the falling edge. So the falling node, right? This is my only winner node. I cannot change any edges. My k is equal to 0, so I cannot change any edges. So my only possible winner is the falling node, that is 1. So I can just place 1 here, and I know it will always win, right? Because it is the only possible winner. So my answer is how much? My answer is equal to 1. And the binary form of 1 is how much? We can see the binary form of 1 is 0, 0, 0, right? So that is the only possible binary winner, right? That is the binary representation of the winner. That is my binary winner. The binary code of winner, you can say binary code of winner. As there is only one possible winner, so there is only one possible binary code of my winner. So that is when my k is equal to 0. That is when my k is equal to 0. What about the case when my k is equal to 1? What about the case when my k is equal to 1? So let's draw that case when my k is equal to 1. So we have again the 8 nodes, 1, 2, 3, 4, 5, 6, 7 and 8. We again have 1, we again have 3, we again have 5, we again have 7, and we again have 1, we again have 5, and we again have 1, right? So my k is equal to 1. So I have to like change at least one edge. Sorry, I have to change one edge, right? So here I have my edge 1, or I can call this bit 1 or bit 0, bit 0, bit 1, bit 2, right? So this is 0, 0, 0. So I have my bit 0, bit 1, bit 2. These are all zeros, right? Because all of my edges are left sided. So now my k is equal to 1. So I have to change at least one outcome. So, or exactly one outcome, right? So changing outcome, if you see, if I change my outcome from let's say from 1 to let's say 5, then basically what I am doing is I am changing a left edge to a right edge. I am changing a left edge to a right edge. Or you can say I am toggling or flipping. I am toggling my 0 to 1. Toggling my 0 to 1, right? That makes sense, right? Well, because when you change outcome, you are basically flipping 0 to 1. So initially my winner is how much? My winner is 0, 0, 0. And now my k is equal to 1. So basically I have to flip one of these. I have to flip one of these bits. So if I flip the, let's say, first bit, so if I flip bit 0, that is the first bit. So if I flip bit 0, my winner will be who? My winner will be, if I go down the path, it will be 5. So if I change bit 0, my winner will be who? It will be 1, 0, 0. So that is my winner will be how much? It will be 5. Right? So that is the binary code of 5. So this is 1, this is 0, this is 0. Similarly, if I flip bit 1, I have 0, 1, 0. So my winner will be who? We have 0, then 1, then 0. We have 0, 1, 0. So my winner will be 3. Answer is 3. Similarly, if I swip the last bit, it will be who? It will be 0, 0 and then 1. So it will be 2. So my answer is 2. Right? So I have 3 possible winners. My answer is 5, 3 and 2. Right? Because I have to flip exactly one bit. So either this will be winner, either my 3 will be winner, or either my 5 will be winner. And obviously I can choose to not flip any bits, right? Because if my k is equal to 1, there's also possibility that I do not, like, if my k is equal to 1, then I can also choose k equal to 0, that not toggle any bits, not toggle any bits. So in that case, my answer will be 0, 0, 0. So my answer will be 1 itself. My answer will be 1 itself, right? So now I have 4 possible winners: 1, node 1, node 2, node 3, and node 5. Obviously, the committee wants to maximize the answer, so they will obviously go for the 5th node, right? So they will always flip the first bit. They will obviously flip the first bit. So like they will go to winner as 5, and obviously I don't want that. So what I can do is I can like place 4 here. I can place 4. So instead of 5, I can erase 5, and I can place 4 here, right? So now the best answer that I can have is 4, right? Because committee will always go try to maximize the answer. So my best answer will always be 4, right? So I hope the answer is clear, right? Because how many bits do you have here? The number of bits here is equal to number of rounds, right? The number of bits are equal to number of rounds, and my k is equal to 1. So I had to flip 1 bit. So how many ways are there to flip 1 bit among like n bits? So it is nc1 or nck, you can say, right? So I had to flip 1 bit. So there are nc1 ways, or there is 3c1, right? Because my n is equal to 3. So I had 3c1 ways. So I had 3 possible winners, right? Because I had 3 ways to like flip the bits. So I had 3 winners. And there was also a case when I do not flip any bit, that is k is equal to 0. So in that case, my winner are how much? nck, that is equal to nc0, that is equal to 3c0, so that is equal to 1, right? So there is only one possible winner when I decide not to flip any bit. So my answer is equal to 1 in that case, right? So in total, I will have how many winners? I will have nc0 plus nc1, right? So in total 1. So if my n is equal to 3, so I will have 1 plus 3, that is 4 possible winners. I will have 4 possible winners, and I will assign them nodes from 1 to 3, 4, right? And my first answer will be how much? It will be 4 itself, right? So I will assign these nodes 1, 2, and 3, 4, and obviously the committee will choose the node with value 4. Right? So my answer is how much? Answer is 4. Or you can directly say my answer is how much? It is just equal to nc0 and nc plus nc1. So that is how it will work. So I can draw another example for k is equal to 2, and I think that will like help you see the solution better. So if I have, let's say, k is equal to 2, first there's one case that I choose k equal to 0 and I decide not to flip any bit. So I will have my value as 0, 0, 0, right? So that is answer is equal to the first node. Then I have my k is equal to 1, that is I decide to flip 1 bit. So I can flip either the first bit, either the second, or either the third. Right? So answer is equal to 2 here, I think. Yeah, answer is equal to 3, answer is equal to 5. And for k equal to 2, you can flip any 2 bits. So you can flip either, let's say, 1, 0, 1, 1, 1, 0, or 0, 1, 1. So you have your answer is equal to how much? This is your node right, left, right. So this will be 6, I think. This will be 7, and this will be, I think, 4. Yeah. So how many winners do you have? You have like nc0. So you can say 3c0 in this case, 3c1 in this case, and 3c2 in this case. So in total you have 7 winners, right? And you can place 1, 2, 3 up to 7 in these 7 nodes, and the committee will choose the worst one. So they will obviously choose node 7. So your best answer can be node 7. Okay, so that is your answer. So I hope it is clear, right? I hope the binary thing helped you like see the answer. How like I think the binary like was really helpful in finding the answer, right? So like if you are able to see the edges as bits and changing the outcome as flipping of bits, it will help you see the answer very well, because it really helped in my case. Yeah, so that is the solution, and I can write it formally for you or summarize it once again. So the summary is that if your number of rounds are n and you can do k flips, then your answer is how much? Your answer is just summation of I goes from 0, minimum of n comma k, nc I, right? Like for example, if your k is equal to 2 and your n is equal to 3, then your answer is how much? Your answer is nc0 plus, so not nc0, I will this 3c0, 3c0 plus 3c1 plus 3c2. That is, you flip 1 bit or change one outcome. You change 0 outcome, you change 1 outcome, and then you change 2 outcomes, right? So that will be your answer. And if you guys want to see the code for this, here's the code, right? You just find ncr and you just like do the mod, And if you guys don't know how to like find NCR modulo, it is a well-known thing called Fermat's theorem. So you can look it up online on Geeks, you will easily find it. I can do it for you guys. Fermat's theorem. It is a very well-known theorem. You can find it on Geeks site. So you can read this if you guys like find it hard to implement. But yeah, that is it. And like you just go from 0 up to minimum of n comma k, and you just add to your answer ncr n comma I, right? And then you just like do the mod of it, and in the end you can just print your answer. So I hope the answer is clear. And if you guys have a doubt, like I said in the beginning, you can join my Discord server, and I'll be more than happy to answer doubts there. Yeah, so that is it. That is it for this video, and I will see you guys in the next one. Bye bye. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is zero hidden fees, there is zero upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. You can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long, and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below, and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.